Hello my dear students, welcome back to NEET WORLD. So we will be continuing our discussion on chemical kinetics. Okay, so this is our third session on chemical kinetics for EAPCET 2026. Okay, yes, so these sessions are useful if you are preparing for EAPCET 2026 or NEET, also NEET and JEE also. Okay, so just practice these questions along with me in every session once after completing discussion of that particular concept. That will helpful for your upcoming exams. Okay, right. So now in this session we will be discussing the effect of temperature and rate of a reaction. So let us look what we discussed in the last class also. Yesterday I have started discussing about effect of temperature, effect of temperature on rate of a reaction. Okay, it is very easy, you can easily understand this. Look at here, see, when temperature is raised, rate of a reaction also increases. If temperature increases, rate of a reaction also increases. Now the relation between this temperature and rate of a reaction is given in this way. See, this K represents rate constant. So if temperature increases, rate constant also increases. That rate constant increases means rate is also increases, because K into concentration of A power m we are saying. So if K is more, then rate also more, no? Right. So if temperature increases, the rate constant increases, that is nothing but rate of a reaction also increases. Now here it is observed that experimentally for every 10 degrees rise, in temperature, rate of reaction increases 2 times. It means what I am saying, if at a temperature T Kelvin, if rate of a reaction is R1, then the temperature at T plus 10 degrees Celsius, it becomes 2 R1 times. The rate becomes R2 becomes 2 R1. Okay, R2 becomes 2 R1. This is what you can remember. Okay, so now what I am saying, for every 10 degrees rise in temperature, rate of a reaction doubles. Okay, so it sometimes it might be triples also. So there will be variation from 2 to 3. Okay, if there is nothing mentioned, you consider it as minimum number 2. If in the question they have specifically mentioned 3, then you can take it as 3. Okay, if not mentioned, you take it as 2 only. Okay, hope this is clear. Now question will be like how many times rate increases if temperature rises from some 20 degrees to some 40 degrees, if they say, see, 20 to 30, 30 to 40, it means at 20 degrees Celsius, if it is R, it becomes here 2R right now, and here it will become 4R. It means the temperature, the rate at this 40 degrees Celsius will be equals to 4 times of rate at this 20 degrees Celsius. Rate at this 20 degrees Celsius, that's it. This is a relation. Now the exact relation of this temperature and rate of a reaction is given by Arrhenius equation, where it gives K is equals to A e to the power minus EA by RT. This is a relation we have. Okay, and questions and calculation about related to this thing were discussed in the last class also, but I just wanted to give you some clarity again, so that we can solve some numericals related to this particular discussion. Okay, so just look at here very consciously, so that we will get complete clarity. See, I have K is equals to A into e power minus EA by RT I am writing, where here the units of K and units of A are same here. What I am saying, the units of K and units of A are same. Okay, so if the units of K is second inverse, that is for first order reaction, then units of A also, it will be second inverse now. Then you can say this is frequency factor. What is that? Frequency factor A in case of first order reaction. So for other order reactions, A is called the free exponential term or Arrhenius parameter, you can say. Okay, right. Now how can we write these? K by A is equals to e to the power minus EA by RT we can write. So now there are some graphs related to this particular equation, like ln K by A is equals to minus EA by RT. So based on this you can expect a graph like this, ln of K by A versus 1 by T here. So how they related? See, this is Y with a negative slope, or they can give it as, or they may give it as temperature. All these discussions were completed in yesterday's discussion. And next, what you can make here, ln of K minus ln of A is equals to minus EA by R into 1 by T you can write. So I have a question on this, I will show you now. ln K is equals to now minus EA by R 1 by T plus ln of A you can write right now. So this is the equation we can use here. See, let me show you one question. Just look at here what they are saying. They find the correct relation among the following. Very easy now. This is EAPCET question. See, right, without having any confusion you can easily answer this. Just tell me what will be your answer. See, just now we got ln of K minus ln of A is equals to minus EA by R into 1 by T we got right now. So do we have any relation like this, ln of A minus ln of K? Here it should be minus, not mentioned, means this is wrong. This is also wrong. Next, see, this is also wrong. Just consider these ones. So what they are saying, EA by RT is equals to, it means they just multiplied with negative both sides. Then we will be getting EA by RT equals to ln of A minus ln of K, that's it. Just multiply this equation with the negative, okay, minus 1, they will get this option. So option D will be perfect equation from the 4 options right now, right. So this is clear, right. So let's see some questions related to graphical representation. So graphical representation, see here we have a question for a first order reaction. For a first order reaction, the temperature T depend on rate constant K was found to be the following equation. Okay, this is the equation for the first order they are saying. Log K equals to minus 20 by T plus 4 they are saying. The activation energy EA and pre-exponential factor A respectively from the 4 options. Okay, so easily you can solve this. Look at this, whatever I am explaining here. See, we got ln of K is equals to minus EA by RT, that is 1 by T plus ln A we can write, and this is given in terms of log now. So in the question it is mentioned in terms of logarithms. So what to take here? So just, I hope it is visible. If not, let me set the screen first. Yeah, it is visible properly. So now what to take here? See that they are giving it as log, so you can mention it as log K is equals to minus EA by 2.303 R 1 by T plus ln A, log A. Okay, like this you can say. Now compare the given equation with this particular equation. See, wherever we have minus 20 by T, there we have minus EA by 2.303 R into 1 by T we have. So this is nothing but minus 20 is equals to minus EA by 2.303 R, that's it. Okay, that's it, because 1 by T, there also 1 by T. Then next, from this you can say activation energy EA will be equals to 20 into 2.3 into R. See, they are asking our answer in terms of calories. So R can be 2 calorie per Kelvin per mole, now 2 calorie per Kelvin per mole. If they ask the same answer in terms of joules, you can say R equals to 8.314 joule Kelvin inverse mole inverse you can take. Okay, so here since it is in calories, you can take 2 here, that's it. So by simplification, how much it will be? It will be 23. The next 92.12 you will get here. 92.12 will be the answer for this particular question here. Okay, EA you got. Okay, along with that, they are asking found to be follow this equation, the activation energy and pre-exponential factor A. Okay, so here A is nothing but log A. In the place of log A, we have 4. So that is just by comparing both equation, we will get log A is equals to 4. Then A will be no log, you can write 10 power 4. That's it. So A is 10 power 4 and activation energy is 92.12. So here we have option B as our answer for the question. Hope this is also clear right now. So if the things are clear, just mention clear in the chat box. Yeah. Yeah, let's move forward with few more questions. If you have any concerns or any doubts, just mention in the chat box, I am looking into it. Okay, the next. Yes, Akhil, okay, right. Next, we'll solve few more questions. Look at this. We have one more question here. For a reaction taking place in 3 steps at the same temperature, the overall rate constant K is given as K1, K2 by K3. See, a reaction is taking place in 3 steps at same temperature they are saying. Then the overall reaction rate of that reaction, overall rate constant for the reaction is given as K, which is equals to K1, K2 by K3 they are saying. This is JEE Mains 2024 question. Easy, just follow here. I will tell you one simple trick. See what we know K means. I will tell you one simple trick. Before that, understand the concept here. See, K means what we know, A e to the power minus EA by RT we can write right now. So for K1 it should be EA1. If this is K overall, this should be K overall. This activation energy should be overall. Okay. So if it is K1, you should take A e to the power minus EA1 by RT, like that. We need to take everything and we need to substitute here. So upon simplification by keeping all these K terms here, like these things, Arrhenius equations here, you will be getting a final equation as if K overall is given. So K overall will be, E overall will be equals to, wherever we have K1, there you write E1, EA1, okay, plus, see if it is in the numerator, you just write plus EA2. If it is in the, if the given K3 is in denominator, write that as minus EA3. That's it. This is a final equation you need to take to get the answer. Okay. Actually what to do? So wherever we have K1, you should insert this, and K2 means again e to the power minus EA2 by RT, like that we need to write for everything. Upon simplification, you will be getting an equation like this. What is that equation? Wherever the things are multiplied, if in the numerator are there, if they are multiplied, then their activation energy should be added. If that is in the denominator, you should write as a minus of that what particular thing which is in denominator, like EA1 plus EA2 minus EA3. That's it. This will be the final equation. So now look at this. What is the value mentioned for EA1? 40. Take here it as 40. And EA2 mentioned as 50. Take here it as 50. And EA3 is 60 here. So 90 minus 60, that will be plus 30. That's it. This will be your answer for overall activation energy of this particular reaction. Okay. Hope this is clear how easy it is. Right. If this is clear, just mention clear. Right. If you want, I will repeat the same thing based on your understanding. Okay, let me check. Right. Next, we will discuss few more questions here. Look at this. The rate constant for a first order reaction was doubled. So what they are saying, the rate constant for a first order reaction was doubled when temperature is increased from 300 to 310 degrees Celsius. Just now we have seen for every 10 degrees rise in Celsius, for every 10 degrees rise in Celsius or Kelvins, there will be the rate will be increasing 2 times right now. So at 300 degrees, if it is R1, rate equals to R1, then at 310 degrees it will become 2R1. That's it. R2 becomes 2R1. R2 becomes 2R1. That's it. Okay. This is what they are also saying. Now, what is the approximate activation energy for this particular reaction they are saying? See, simply you can say there is a relation. What is the relation we will get? See, we have finally log K is equals to EA by 2.303 minus EA by 2.303 or 1 by T we got. Finally, this is the equation we got. Now, at temperature K1, we got this as, see from where we got this equation, we just write K is equals to A e to the power minus EA by RT we have now. From this what we got? So, like A you bring this side, then exponential term also it becomes log here, ln becomes, then next you got finally log K is equals to minus EA by RT 2.303 or 1 by T plus log A we got. This is the final equation we got. So now at temperature T1, you can see rate constant as K1. Therefore log K1 will be equals to minus EA by 2.303 or by 1 by T plus log A you can write. And at temperature T2 you can write log K2 will be equals to minus EA by 2.303 or 1 by T2 plus log A you can write. So now just to do log second equation minus first equation, this is if it is first equation, second equation. So 2 minus 1 you can say, therefore finally we will be having log K2 by K1. From these two equations we are going to get this log K2 by K1 is equals to EA by 2.303 or 1 by T1 minus 1 by T2. This will be the final equation to be used in this particular question. So this is very, very important. There are 3-4 times same question is asked in different ways. I am saying 3-4 times same question is asked different ways. See here, same question with 310 300 degrees Celsius, they are asking rate increased 2 times now. Same question here, see again in 2024, 2022, 2020. Same question, see again 300 to 310 degrees reaction doubles. Same thing, see here 27 degrees is nothing but 300 Celsius, 300 Kelvin, and 37 degrees means 310 Kelvin. So same question asked multiple times. Not even similar, same question only they are asked with the different terminologies they used. Okay, right. So this is how it is very important to be practiced here. That's why effect of temperature and rate of reaction, Arrhenius based questions, you just practice 2-3 questions. Otherwise I am going to solve this. Remaining 2 questions you solve, or you take any PYQ book, whether it is NEET, JEE or EAPCET, there will be some questions related to this from PYQs, you must solve them. Okay, and here look at this, what we can say, log K2 is how much? That is nothing but 2 times of K1. So this is 2 K1 and K1 is, I am writing as it is K1. So EA by 2.303 or 1 by T1. So 1 by T1 is how much temperature, lower temperature is 300. So that is 300 minus 1 by T2, that is 310. That's it. So try to simplify this. Here it will be removed. So log 2 means 0.3 we can say as per the data mentioned, and into 2.303, and what about R value? See, they are asking our answer in terms of kilojoules. So you can say 8.314 into 10 power minus 3 kilojoule per Kelvin per mole you can take, okay, which is equals to, you just send this here. So 310 minus 300, how much it is? 10. Okay, so 10 divided by, so EA will be, so into 300 into 310 divided by 10 you will be having this, that's it. So how I am doing? So this is 0.3 as it is. So just send this here, 2.303, R means 8.314 into 10 power minus 3 kilojoule Kelvin inverse mole inverse I have written. The LCM here I have taken and I have sent this side, so that here I have written, and the next the part that is 310 minus 300 will be 10, that is here I have written, therefore we got EA like this. Okay, right. Now this 10 power minus 3, this 0 is removed. So upon simplifying this, finally you will get something like activation energy EA will be equals to 53.2. So around this much we will get kilojoules of energy we will get in this manner. Okay, so now where do we have the nearest option? Here we have is D. So that will be our answer. Even the remaining questions which I have shown here, so that will be also having same values now. So that is 53.5. Yes, this is our answer. Here also you will get around same 53.5 only you will get here also. Okay, all these questions are what? EAPCET questions with the same data mentioned. Okay, right. Yeah. So let me show you a few more questions. Just answer me what will be the answer for this particular question. See, the rate increases 3 times for every, or rate increases 2 times for every 10 degrees Celsius. Then rate at 300 Kelvin is K1 and 320 Kelvin is K2. So K2. Then find activation energy for this particular reaction. So first of all, you need to get what is the relation between this K1 and K2 by using this particular data. So for every 10 degrees Celsius, what I told you, 2 times rate increases. Okay, so it means I have given 300, it is increasing up to 320. So it means 300 to 310, it will, if here it is K, if it is K here, it becomes 2K1 here, and I am saying it is increasing up to 320. So therefore again 10 degrees rise, it means again 2 times increases, so it becomes 4K1. So what is our K2 finally? So K2 will be 4K1, and this is K1, that's it, we got. So log K2 by K1, just substitute the values over here. Log K2 by K1 we have, which is equals to EA by 2.303 or 1 by T1 minus 1 by T2 we are taking na, yes. Just simply substitute the values over here, you will get this activation energy. I hope the concept is clear from the previous question, and also I have given all the hints required to solve this question. Yes, even everything is provided here, just tell me your answer in the chat box for this particular question. Okay, right. Next, let us solve few other questions related to this chemical kinetics only. Okay, let me show you few other questions here. Look at this question. What they are saying, which of the following graph is not for a zero order reaction? See, they are saying first graph representing T half is directly proportional to A, that's why we are getting like this. See, for a zero order reaction, what will be the T half formula we have? So for a zero order reaction, T half is equals to A by 2K0 we will get. How we will get this? All the things were discussed in on the previous parts like chemical kinetics 1 and 2 I have made. You just watch it, you will definitely get clarity on this discussion. Okay, right. So this is the relation between T half of zero order reaction with the initial concentration. So how do they relate? T half is directly proportional to concentration, initial concentration. Now, so you will get this as y is equals to mx type graph. Okay, our x is A and m is our 1 by 2K0. So this is nothing but the graph will looks like this now, T half and A. Yes, this graph is for zero order reaction. They are asking not for zero order reaction. So now look at this graph, x versus t. So how do we get this? This is an integral equation graph. Okay, this is an integral equation for zero order. What is the integral equation? See, you will get x is equals to K0 t is an integral equation for zero order reaction. So from this you can say x is equals to K0 t means you can say this term as y and this term as mx. Then what happens here? So x versus t will give a straight line like this. So this is also corresponds to zero order reaction only. Okay, so if you are not knowing like why x equals to K0 t, just watch the session 1 of this chemical kinetics in this playlist only, in this channel itself. I have discussed its integral equation, differential equation, everything. Okay. Next, look at this question. Look at this question. They are saying dx by dt is having independent of the concentration of reactant. Yes, this is also for zero order reaction. Why? Because see, if a reaction A is giving rise to some product, I am saying if it is following zero order reaction, what we can write? Rate is equals to change in concentration of A with the time dt will be equals to A concentration of K naught into concentration of A to the power 0. So, A to the power 0, something power 0 will be 1 now. So, now see, change in concentration dA by dt is independent of concentration of reactant. Okay. So, if it is independent of concentration of reactant, then the graph will be looking like this only. So, it is independent, see. So, this is also for zero order reaction. Now, look at this graph. This graph is not for a zero order reaction, this is a graph for first order reaction. So, how that first order reaction graph will be? See, you will get so correct option for this particular question is D. Okay. Let me explain you why this graph is for first order. See, so first order integral equation will be given as K1t is equals to 2.303 log A by A minus x we have. Okay, that's it. So, they are saying log A minus x versus temperature. So, you can say log A minus log A minus x is equals to K1 by 2.303 T. You can write in this format right now. So, now they are saying log A minus x versus that thing we require. So, log A minus x is equals to just bring this side, send that side. So, that it will be minus K1 by 2.303 into T plus log A, that is it. So, how it is? Y is equals to mx plus C type graph. So, what is our y here? Log A minus x, and what is our x there? T. Slope will be negative, so negative, and this is our intercept log A. That's it. This will be the perfect representation for your first order reaction, but not for the zero order reaction. Hope the complete discussion of this particular question is clear and the graphs are also clear. Right now, if these things are clear, just mention clear in the chat box again. If you have any confusion, just ask me. I will clarify it. Right. Next thing here, we have one more question related to graphs. See, this question is from EAPCET again. Which are the following is correct? With respect to the given graphs? See, chemical kinetics means there are lot of chance to ask a question from the graphs, because the graphs will varies depending upon the order to order, and whether they are taking whether half life they are taking, or they are taking integral equation or normal equation or differential equation, depends on that graphs will be varying. So, to examine whether you are clear with the concept or not, examiner will definitely choose graphical representation based questions from chemical kinetics. Okay. So, it is very important to see all the graphs related to the all different orders of chemical kinetics. Okay. Right. Next, look at this. They are saying which are the following is correct with respect to the given graph. Okay. See, R is a concentration at a time t, R naught is the initial concentration of the reactant. So, again they are saying with respect to correct which is them are correct. See, 4 statements are given, we need to choose which statement is correct here. See, rate is independent of initial concentration. See, whenever a line is mentioned like this, see, rate is independent of initial concentration, it is being constant, it is not depending on concentration of initial concentration. So, it means what? Rate is not depending upon the concentration of reactant. If it is not depending, you just put here 0. So, it is R is equals to K naught it will become. So, it means which order it is? See, rate is independent of initial concentration now, reactant concentration now. So, which order it is? Here we are inserting 0, then only it is becoming 1 now. So it means what is the order of the reaction? 0 order. So the graph 1 indicates 0 order reaction, whereas graph 2, just look at here, it is indicating like concentration of R versus time. So what to take here? See, this graph is also again for 0 order reaction. How do you get this kind of graph? See, what to take is see, differential equation rate means what you can say? Change in concentration of reactant with time. Right now, since it is a reactant, its concentration decreases, so minus dr by dt is equals to k naught we should write. Like this we are writing. So now we know dr by dt is nothing but minus concentration of R at temperature T2, that is R2, they mentioned it as R, minus initial concentration as R0. Okay, final concentration minus initial concentration. This is at concentration at temperature T2, this is at initial at temperature, that is at T0, T1, that is 0 seconds right now. So this will be equals to K naught. So from this I can write concentration of R naught, just multiply this inside, R naught minus concentration of R will be equals to K naught T. Okay, that's it. Now K naught T will be getting here. Okay, so from here concentration at a time T will be equals to now R naught concentration minus T K naught. So from this we can expect a graph in this manner. See, this is like this is something like y equals to mx plus c graph again. See, y is equals to, this is mx, this is plus c. Okay, so with the slope, negative slope. So here R concentration at time t versus time. So how do they related? So with slope negative and intercept positive. So intercept positive, slope negative means like this. So this is a graph for 0 order reaction. Okay, first two graphs are for 0 order reaction. When it comes to third graph, just look at this graph number 3 here. This corresponds to what? See, they are saying log initial concentration by final concentration, they are saying. So simply it's initial concentration by final concentration versus time. So just now we solved it for 0 order reaction. How do they related? Let's check whether it is 0 order or not. See, 0 order or first order. How can we see here? Take first order equation once T is equals to 1 by K log, they are saying 2.303 by K log initial concentration R naught by A minus X, that is concentration of reactant at a time T, that's it. Okay, so we got in this manner. So then next they are saying, see, yeah, this is what y equals to mx type graph in only now. So log R naught by R will be equals to T or K by 2.303 multiplied with the temperature, that is time here, not temperature, time here. So this is y is equals to mx type graph. Yes, so y equals to mx type graph means slope will be K by 2.303. Yes, this is correct for first order. So where do we have here? 1 and 2 represents 0 order, where 3 represents first order. So option B will be a perfect answer for this particular question. Okay, yeah, I have again clearly discussed the different ways of representation of graphs here. Okay, I hope this is also clear.